Dr. Vivek Shrivastava is an associate professor in a chemistry department at NU. He did his doctorate in the area of heterogeneous organocatalysis from University of Rennes, France. Currently, his research group is working on sensible design and development of catalysis for sustainable processes, which are primarily important to enable the present and future worldwide production of the chemicals while avoiding negative consequences for the environment. State-of-the-art high-pressure experimental techniques are employed in the study of catalytic systems with the aim of promoting scientific research that is fundamental in nature and applied in perspective. They are applying a wide range of synthetic spectroscopic and reaction engineering tools to understand the chemical reactions of the molecules of catalytic surface. Their strong emphasis is placed on the nanoscale fabrication of catalysts by controlling and manipulating the structure of the material. Research projects in his group mainly aim at addressing current issues associated with the alternative energy, renewable chemicals, carbon sequestration, and novel catalyst design. So welcome, sir, in this session. We are starting the session with the first presentation, with your permission. The first participant of the session is Narendra Singh. Narendra Singh ji.
You can go in slide.
Narendra Singh.
Press F5.
Neelam.
Yes, sir. Yes, sir.
Neelam, please carry over from here onwards.
Okay.
Okay.
So, Narendra Singh, can you hear me out? Mr. Narendra?
You can start the next presentation, Neelam.
Okay. So Hariram sir is present here. So I would like to invite Hariram to present.
Yes, madam.
Please share your screen, sir.
Yes, madam. Hello.
Yes, sir. Please share your screen.
Share. Yes, madam.
Sir, please share your screen. All right, sir. If you are not able to share it, can we invite our next candidate?
Some more problem of sharing of screen. 1 minute.
Okay, you should try, Hariram ji. Meanwhile, we'll entertaining another candidate. After that, you should start sharing. Okay.
Okay.
Neelam, you can call the next candidate.
Vaishnavi? Is Vaishnavi here?
Yes, ma'am.
Vaishnavi, please share your screen.
Okay. Okay, ma'am. Okay, my screen is visible to everyone.
Yes, Vaishnavi.
Okay. Hello, everyone. Good afternoon. I am Vaishnavi Mangale and my presentation is on solid automation processing structural, microstructural and magnetic characteristic of neodymium doped with nickel, cobalt, zinc, Fe2O4 spinel ferrite nanocrystal. Yes, the outline of my presentation is introduction, aim of the work, characterization technique, result and discussion, and then conclusion, and last one, references. Here, introduction to ferrite. Ferrite are the ferromagnetic material consisting of iron oxide and metal oxide as their main constituent. They exhibit exceptional electrical and magnetic properties which are valuable in many technological applications. Easy for preparation, chemically stable, and low cost material. Then classification of ferrites. Here's the classification of ferrites uh, in three types. Okay, on the basis of structure, crystal structure, ferrites are classified as spinel ferrite. Okay, which we are taking as our material. Okay, cubic granite. Okay, and then hexagonal ferrites. And now uses of ferrites. Here some uses I have mentioned: electric inductors, transformers, electromagnets, computer memories, in the coatings of magnetic recording tapes, and last one for biomedical applications. Spinel ferrites. Okay. Spinel ferrite with general formula Fe2O4 and sorry, MFE2O4, and M is like cobalt, nickel, etc. Okay, are very important magnetic material due to their combined properties of magnetic conductor and electrical insulator. And then in the family of ferrites, over many years, spinel ferrites have been the subject of concern due to their wide possibilities of application in electronics and radio engineering. And then the advantages of spinel ferrites as magnetic material are due to their high values, electrical resistivity, high saturation, magnetization, high permeability, low eddy current, and dielectric losses. Now, this we are further discussing about the our method of synthesis. Okay, we are using sol gel autocombustion method for the preparation of our spinel ferrite. Why sol gel autocombustion method? Among the conventional wet chemical, sorry, non-conventional wet chemical processes of obtaining oxide materials, the sol gel method is mostly used method in scientific and industrial field. And then sol gel technique have become very popular recently due to their high chemical homogeneity, low processing temperature, and the possibility of controlling the size and morphology of particles. Sol gel approach is cheap and low temperature technique. Okay. Then aim of our work. The aim of our present work was to synthesize neodymium ions, though nanocrystalline, nickel, cobalt, zinc, mixed ferrite chemically expressed as Ni 0.5, Co 0.3, Zn 0.2, Nd 0.5, Fe 1.5, O4. Okay, by sol gel autocombustion technique, and to study their structural, microstructural, and magnetic properties. Next, synthesis of the sample by sol gel method. Okay, here we have discussed about the synthesis. Okay, by this flowchart. Here, first cobalt nitrate, we are using nitrate compounds. Okay, cobalt nitrate, nickel nitrate, zinc nitrate, neodymium nitrate, ferric nitrate. With glycine, we are stirring and heating at 90 degrees Celsius on our apparatus called magnetic stirrer with a hot plate. Okay. Then continuous stirring at 90 degrees Celsius, we get a gel material which then mixed with ammonia solution and dried the gel. Then we got a a clear solution. Then we make a powder sample. Then we put that powder for annealing at 800 degrees Celsius, and we get our final product as a spinel ferrite. Okay. And then characterization technique. Here are some characterization techniques that I have used. The prepared nanoparticle were characterized by X-ray diffraction, transmission electron microscopy, magnetic were investigated using the vibrating sample magnetometer technique. Okay. Then result and discussion. Here the X-ray diffraction analysis and the highest peak as 311 and the X-ray diffraction analysis indicate the formation of cubic spinel structure without any impurity phase. Average particle size we have calculated from the Secher's formula. The average and found to be in nanometer range 45 nanometer. D is equal to 0.9 lambda upon beta cos theta, in which lambda is X-ray wavelength and beta is full width at half maximum. Okay. FWHM is the abbreviation and theta is Bragg's angle for the peak 311. Okay. Here other structural parameters determined using XRD data. Okay. Lattice constant, unit cell volume and bulk density. Okay. This is transmission electron microscopy. Our sample image 10 has shown formation of spherical shaped particle in nanoscale. Here magnetic properties using this VSM. And then conclusion. The X-ray diffraction analysis indicates the formation of cubic spinel structure without any impurity phase. The average particle size was obtained by Secher's formula and found to be in the nanometer range, 45 nanometer. Okay. Then transmission electron microscopy study evidences that spherical uniform nanocrystalline powder were successfully synthesized. Then results also supports the approximate size of the nanoparticle initially derived from XRD data. Magnetic properties were systematically investigated by vibrating sample magnetometer technique. Various parameters like saturation, magnetization, okay, HC, remanence, magnetization, MR, okay, and remanence ratio MR upon MS were calculated from MH hysteresis plot. Okay, then the sample exhibits well-behaved hysteresis loop typical of ferromagnetic material. The obtained characteristic can be useful for technological and biomedical applications. Here are some references and thank you.
Thank you so much, Vaishnavi. It was a wonderful talk and presentation. So I would like to invite Vivek sir if he has any question or suggestion to Vaishnavi.
Yes, Vaishnavi, I just want to ask one thing. From XRD, whatever data you showed, how you concluded that you have synthesized some cubic structure?
By calculating that peak value 311. Sorry. Hello.
Yes.
The peak value from which
I'm
I
not
have
getting.
concluded 311.
Hello.
Yes.
Yes.
Vaishnavi, your voice is not clear. Please speak loudly.
Okay. I'm audible now.
Yes.
Yes, Vaishnavi. Try to
I
answer
have
the question.
calculated, yeah, by that peak value.
What is the peak?
Okay, that parameters which 311.
But where is this parameter P11 in the peak?
Yes, I have
Okay,
shown.
300 Yes. Okay.
Yeah.
311 you are getting the, that's you are saying that that's a cubic spinal structure. Okay, tell
Sir,
me
do you
another thing. Why you are using glycine?
Glycine.
Yes.
That because the glycine converts that into gel, and which is easy to dry the material.
Okay. Okay, thank you, Vaishnavi.
Okay, thank you, sir.
Okay, thank you, Vaishnavi. And I would like to also ask one question. Can you please tell what is this peak indicates to you? Like you have marked the in XRD spectrum that 311, 211. What are these parameters? You are saying these parameters. What are these?
Ma'am, these parameters, our crystal dimensions in that directions.
Fine. So thank you so much. Now I would like to, Vaishnavi, you can close your screen.
Okay,
Okay. So
already
I would like
closed.
to invite our next candidate. Narendra, are you ready with your presentation? Please share your screen, Narendra.
Hello.
Yes.
Narendra.
Good evening, all of you. Myself, Narendra Singh. My research topic is study of physico-chemical parameters of irrigation water of Sikar district with its impact on quality of soil. My research guide is Dr. N.P. Lamba sir. Abstract. The present topic revolves around the study of physico-chemical parameters of irrigation water of Sikar districts, its impact on quality of soil. In this study, we are using various parameters like pH, electric conductivity, TDS, dissolved oxygen, turbidity, salinity, total hardness, calcium alkalinity, magnesium, chloride, nitrate, sulfate, sodium, potassium, calcium, iron. And we have used various methods consisting of SAR, sodium absorption ratio. Keywords: groundwater pollution, agricultural activity, irrigation water quality, impact on soil, secret district. Introduction. Water crisis is a worldwide problem, especially in desert ecosystem. To overcome this shortage, saline groundwater is increasingly being used, though it has risk of increasing soil salinity and causing plant salt toxicity. In this study, we investigated the effects of salinity water irrigation on soil property and plant growth along the Sikar district area. The results show that soil salt and nutrients significantly accumulated at the soil surface crust and 0 to 10 cm soil layer centimeter with salinity irrigation, but the soil salinization did not increase within the 40 to 60 centimeter soil depth where abundant lateral roots also germinated and extended horizontally. Present in the 20 to 18 centimeter soil depth of the three species along no active absorbing roots were found within the 0 to 10 centimeter soil depth where the salt had accumulated. The changing time invite discussion of the sustainability of irrigated agriculture in future with the climate change, with environmental pressure from logistics and the public, and with the demand of powerful produce buyers. One of these environmental impact is of course upon the soil itself. Irrigation even with water of high quality often represents a large increase in the amount of water which would pass through a soil profile under natural conditions and has the capacity to accelerate minerals weathering to transport and each soluble and colloidal material to change soil structure and rise to local water table. Soil structure and its significance for plant growth. The phrase soil fertility is frequently associated with the chemical fertility of soil as determined by nutrients and pollutants. This view neglects the physical aspects of fertility which are embodied in soil structure whose importance has been recognized in numbers published review. Irrigated agriculture consumes 16 to 80% of the total water usage and contributes nearly in 38% of the global food production. In the present study, Sikar district Tehsil Lakshmangarh and Fatehpur Shekhawati was selected from 10 irrigation water and 10 soil samples were collected from the following area. Sikar district Tehsil's water sample were collected from different locations, Lakshmangarh and Fatehpur Shekhawati Tehsils. Various peoples are engaged in farming and they use this tube well and deep tube well water for irrigation field. No other means like tube well and deep tube well is present for irrigation purpose. No other means like tube well and deep tube well is present in irrigation purpose. The plant crops growing here show early maturity but have many disorders like necrosis, chlorosis, attenuating growth, leaf dieback, etc., which might be due to use of this tube well and deep tube well water. There is a strong possibility of accumulation of heavy metals in plant and crops. Experimental. Irrigation water and soil samples were collected from the following Sikar district areas consist of Lakshmagarh and Fatehpur Shekhawati. We took 20 samples, 10 of soil and 10 of water respectively. After collecting samples were brought to laboratory and following physicochemical and soil sample test shall be conducted. pH by pH meter methods, electric conductivity by conductivimetry method, TDS by TDS in ppm per part million, total hardness, total alkalinity, chloride by titrometric methods, sulfate by turbidimetric methods, nitrate by spectrophotometrically method, fluoride by ion selective method. Spectrometers results and discussion. There are 9 tehsils in Sikar district and all the tehsils have their unique geological, historical and cultural features. Lakshmagarh and Fatehpur Shekhawati tehsil are plain land having great agriculture and irrigation dependence on groundwater. Fatehpur tehsil is totally desert with saline groundwater and no irrigation. Also, tehsil depending soil on groundwater, but the groundwater potential in these tehsils is very low. The results often are presented in table 4. We use various methods such as pH, electric conductivity, TDS, alkalinity, total hardness, calcium, magnesium ion, sulfate ion, chloride, nitrate ion, chloride ion, sodium ion, potassium ion, SAR for determining the physical chemical parameters of the sample collected in both Lakshmagarh Tehsil and Fatehpur Shekhawati Tehsil. Physical chemical parameters in irrigation water sample of Lakshmagarh and Fatehpur Tehsil. pH in Lakshmagarh Tehsil 7.2 to 8. Electric conductivity 20202 2300. TDS 10502 1505. Alkalinity 3902520. Total hardness 3402 610. Sulfate ion 76296. Chloride ion 2902 405. Nitrate ion 9216. Fluoride ion 1.92 3.0 at Fatehpur Tehsil. Physical chemical parameters of soil sample in Lakshmagarh and Fatehpur Tehsils as below. Parameters of irrigation, groundwater and soil. pH of water. Lakshmagarh and Fatehpur Tehsil normal pH range, irrigation water and soil in each area. Electrical conductivity. Lakshmagarh and Fatehpur high electrical conductivity range, irrigation water and soil. It is not suitable in plant growth in each area. Total dissolved solids TDS. Lakshmagarh and Fatehpur total dissolved solids high value irrigation water and soil in each area. It is not suitable in plant growth. Table number 1 and table number 2. Total hardness. Lakshmagarh low range irrigation water and soil in each area and Fatehpur Tehsil have high value in irrigation water and soil. Table number 1 and 2. It is not suitable in plant growth in each area. Total alkalinity. Lakshmagarh and Fatehpur high value of irrigation water and soils. It is not suitable in plant growth in each area. Sodium. Lakshmagarh and Fatehpur high value in irrigation soils in plant will cause screening growth and inactive cell development. Lakshmagarh and sodium absorption ratio low range irrigation soil in each area and Fatehpur have high value of irrigation soil. Potassium, Lakshmana and Fatehpur, normal potassium range, irrigation soil in each area. Calcium, Lakshmana and Fatehpur, high value in irrigation soil, high value play particularly vital role in manufacturing plant tissue and permit it to grow high. Magnesium, Lakshmana and Fatehpur, magnesium low value in irrigation soil, deficiency symptoms of initial iron deficiency, anemia, its seems in order use. Sulfate, Lakshmana Fatehpur, low value in irrigation water and soil. Sulfate deficiency, the effect on its plant is characterized by uniformly thick plant and stunt growth. Chloride, Lakshmana, it is normal, but in Fatehpur, it is high maximum at 1460 ppm. It is found that chloride ion affect plant through osmotic adjustment such as trigger pressure, leaf water potential, and osmotic potential. Nitrate, Lakshmana and Fatehpur, low value in irrigation water. It is in low limit at 9 to 39 ppm, and because of its plant become yellowed with stand growth and produce similar fruits and flowers. Fluoride, Lakshmana and Fatehpur, low value in irrigation water. Nitrate then can affect the blood cancer carrier oxygen and can cause methemoglobinemia, also known as blue baby syndrome. Low value in the plant because yellowed. Conclusion. The current study that we are studying is focused on the physico-chemical parameters of irrigation of Sikar district with its impact on quality of soil. For the purpose, took sample of irrigation groundwater and irrigation soil, and by the help of various parameters such as pH, acid, TDS, alkalinity, total hardness, calcium ion, magnesium ion, sulfate ion, chloride ion, nitrate ion, fluoride ion, sodium ion, potassium ion, and LCR. We founded the irrigation groundwater sample pH is in suitable limit. Electroconductivity is normal in Lakshmanagarh but high in Fatehpur Tehsil. TDS is normal in Lakshmanagarh Tehsil but high in Fatehpur. So does the total hardness is in normal limit but high in Fatehpur. Alkalinity is normal in Lakshmanagarh but high in the Fatehpur. So thus, fluoride and chloride are some parameters such as nitrate and sulfate are lower than the normal limit. References. Thank you.
Thank you, Naren, for this wonderful presentation. Now, I would
Welcome.
like to ask her if he has any comment.
Yes, I just want to add some 2 or 3 things. So first of all, Narendra ji, if you check your slides, so there are a lot of typo mistakes are there, errors are there. Like first slide में आप जाइए, आपने pH में दोनों P और H दोनों कैपिटल लिख दिया, जबकि pH ऐसे लिखा नहीं जाता है, small p कैपिटल H होता है.
Yes, sir.
ठीक है, फिर आपने एक जगह रेशो लिखा है, रेशो की जगह आपने राशन लिख दिया है. थोड़ा उसको ध्यान रखिए कि ऑटो करेक्ट का मतलब ये नहीं होता कि वो जो बता रहा है सब करेक्ट है. ठीक है, आपको अपने हिसाब से करेक्ट ढूंढना है, ऑटो करेक्ट के चक्कर में मत फंसिएगा.
Yes, sir. सॉरी, जल्दबाजी में थोड़ा सा हो गया वो मिस्टेक.
ध्यान रखिए.
Yes, sir.
जैसे आपने सल्फेट आयन लिखा है तो आपने SO फर्स्ट -2 फिर 4 लिखा है, जबकि गलत है, वैसे नहीं लिखा जाता उसको सल्फेट आयन को.
Yes, sir.
हाँ, तो थोड़ा ये टाइपो वाला पार्ट आप देखिए.
Yes, sir.
अगर आप जरा टेबल पे जाएं, देन आई कैन एक्सप्लेन यू समथिंग एल्स. हाँ, ये है. तो लेट से अगर आपने मिली इक्विवेलेंट पर लीटर पे आपने निकाला लेट से, तो पहला तो ये फिजिकल का पी बड़ा कर देना आप नेक्स्ट टाइम से, आप थोड़ा ध्यान रखिएगा.
Yes, sir.
अब ये EC क्या है, इलेक्ट्रिकल कंडक्टिविटी क्या है, ये कंडक्टेंस क्या है ये,
Electrical conductivity, sir.
तो ये भी मिली इक्विवेलेंट पर लीटर निकलती है।
नहीं सर, ये सर सेम एक डेटा।
तो इसका यूनिट अलग है ना,
यस सर।
तो आप टेक केयर करो इस चीज के लिए कि ये यूनिट अलग है। जैसे पीएच है, आपने तो लिख दिया, इसका मतलब है नीचे जितना डेटा है वो सब मिली इक्विवेलेंट पर लीटर है।
यस सर, यस।
ठीक है, लेकिन ऐसा है नहीं।
यस।
दूसरा, आपने ये तो दे दिया लक्ष्मणगढ़ और फतेहपुर का, स्टैंडर्ड डेटा क्या होना चाहिए इरिगेशन वाटर के लिए, वो कहाँ लिखा आपने? मैं कैसे कंपेयर करूंगा कि जहां कहाँ डेफिशिएंसी है और कहाँ डेफिशिएंसी नहीं है? तो आपके पास स्टैंडर्ड सैंपल की एनालिसिस का डेटा है कुछ?
ये सर अभी इस स्लाइड में तो नहीं है, लेकिन जो मेरा जैसे पेपर है उसके अंदर ऐड किया हुआ
हाँ,
है।
तो वो इसमें आपको डालना चाहिए ना। लेट से अगर आप बता रहे हो, जैसे आप अगर ब्लड टेस्ट भी कराओगे तो एक स्टैंडर्ड डेटा रहता है और उसके रिस्पेक्ट में आपको जो
स्टैंडर्ड। यस।
डेविएशन है वो बताया जाता है।
यस सर, रेंज होती
ठीक है, तो वो डेटा हमेशा होना चाहिए, तभी तो हम कंपेयर कर सकते हैं, नहीं तो
है।
कैसे
यस।
करेंगे कंपेयर?
यस सर।
ठीक है, तो यही मेरे कमेंट्स हैं, थोड़ा सा ध्यान रखिए नेक्स्ट टाइम से। ठीक है,
यस सर।
थैंक यू।
थैंक यू सर।
ओके।
Okay, Naren, thank you so much, and thank you so much, sir, for the valuable comment.
वेलकम।
So now I would like to invite our next candidate, S.H. Nimkar, sir. Sir, are you here?
Yes, ma'am.
Nimkar, sir. Yes, sir. Sir, please share your screen. Naren, please.
Please, madam, permit me to share my screen.
Sir, candidates are already permitted to share their screen. Sir, please try to share.
My slide is visible, ma'am.
Yes, sir.
Good afternoon, Vivek sir.
Right.
I'm Dr. Shrikant Nimkar. I'm I'm working as an assistant professor in Sri Shivaji Arts, Commerce and Science College, Akor, which is situated in Maharashtra. My paper topic is studying the conducting polyaniline SNO2 nanocomposite thin film for CO2 gas sensor. So I'm taking this topic for in the convenience of, because the carbon dioxide which is to be increasing in our environment, the percentage of carbon dioxide gas is increasing in our environment, so it is very hazardous if the percentage is going to be more. So that's why to detect them and monitor them, monitor it, we have to develop some instrumentation which is to be like a sensor or electronic nose. So the flow of my paper is like that: carbon dioxide gas sensor, what is the necessity of that carbon dioxide gas sensor, and conducting polymer, metal oxides, nanocomposites, synthesis technique, resultant discussion, and conclusion and references which I have used. So as we know, due to the greenhouse effect or due to the increasing the industries and the automobile industry, there is a lot of gases are emitted, and due to which the environmental disabilities are happened. And one of the gas, that is the CO2 gas, is a very important factor for the health issue. That's why the temperature of our earth also increasing. All of you know that. So, but my point of view, my paper point of view is that those workers or those human beings which are working in an industry where the carbon dioxide gas is potentially used, like a beverage industry, mining or drugs, where the carbonated drinks are prepared, where the carbon dioxide gas is continuously using by that workers or employee, and that's why these peoples are continuously exposed to that carbon dioxide gas. According to the world, according to the data, it is found that if a carbon dioxide gas is not affect on your body when you are when that gas is not exposed to our human body more. For example, it may be it up to the 5,000 ppm. But if the level of that exposing is more than 5,000 ppm, it up to the 8,000 uh, 8,000 ppm, then it will be a dangerous to our health. It may be uh, it may be cause for the uh, potentially it may be cause for the death also if the concentration of this gas is potentially high. But where this happen, where that workers work or they are continuously in a contact with the carbon dioxide gas. So I have mentioned here the some part, that is a soldier working underwater submarine. So in submarines, carbon dioxide continuously emitted by the machineries also, and some the human beings or the soldiers which are working there, that the continuously emitting of the carbon dioxide which is not coming out. That's why how to it monitor and how you can get control into that submarine. That's why there should be some monitoring system should be there. That's why we need the carbon dioxide gas detector. So how this carbon dioxide gas can be detected? So there are so many researchers are working upon it, and so many materials, so many synthesis techniques have been used by the so many researchers. So from this, I'm picking the conducting polymer. So conducting polymer is a novel material which are easy to synthesis, and it is easy to processability. And in conducting polymers like polyaniline, polythiophene, polypyrrole, and their derivatives have been used as an active layer of the gas sensor, because it is an organic material. And if you are using this conducting polymer for the sensors, and when any gas particle is deposited on that material, it can its parameter can be changed. That is a chemo absorption, we can say, and due to which we can measure it in the form of electrical parameters or in the form of temperature rise. So whatever sensor we are synthesized or we are prepared or you can design, by using this you can make a available data of how much gas will be detected by that sensor. So conducting polymer is one of the material which can sense the gas. Then uh, and which can be used for the chemical or electrochemical process. Then, and the conducting polymer have again the one important property. It has a good mechanical property, and which allows the facile fabrication of the sensors. Therefore, I am using this characteristics of the conducting polymer to design that sensor. And therefore, but it has some shortcomings also, because it has a low selectivity, low response time. That's why one of the material again I want to introduce, that is a metal oxide sensor. This is a solid state gas sensor. Means you may be heard about the solid state gas sensor, because solid state gas sensors are widely used in the industry to detect the gases like nitrogen gas, ammonia gas, or carbon monoxide gas. So because they are reliable, easy to manufacture, and it has so many application, and we can manufacture in a low price. But the disadvantages of the metal oxide sensors are its sensitivity, stability, and selectivity towards the gases at low concentration. Means at high concentration it works properly, but at low concentration its sensitivity, selectivity, and stability is disturbed. That's why the researchers want to enhance its property. So the researchers are working upon it. And again, one more parameter, it work at higher temperature. Means it can sense the gases more than 200 degrees Celsius, because most of the gases are detected by this type of sensor beyond 200 degrees Celsius. Means the temperature dependent selectivity of that metal oxide sensor. That's why we have to overcome such type of the sensitivity of that metal oxides. That's why I'm using one of the metal oxides from the SNO2, TiO2, zinc oxide. So many metal oxides are used as a gas sensor. So from that, among with them, I'm using a SNO2, that is tin oxide, due to its unique property, because it has this oxygen ions, and it is a acceptor impurity. That's why when the gases are deposited on them, it get react with them, and its conductivity may be changed. It may be increase or decrease, depends upon the redox reaction. So that's why the combination of the organic material and inorganic material, I'm forming a nanocomposite thin film. So what is nanocomposites? Nanocomposites are nothing but it is a form uh, by using two materials or two components, and due to the different properties of the two materials, when we combine it in the form of nanocomposite by using a proper technique, then its mechanical, electrical, thermal and optical property is going to be changed. And the main property is the surface to volume ratio. That is very important property for the gas detection. So in nanocomposites, means we can use two different properties of the conducting polymer and the metal oxides for the gas sensing application. And what are the shortcomings in a conducting polymer and the metal oxide, that can be overcome by that nanocomposite thin film. So that will be, I have studied, and that nanocomposite thin film may be, as I told you, it may be a metal oxides, it may be a polyaromix oxides, or it may be a carbon nanotubes you can use. So, and we can investigate an application else, means we can use as a active layer or active material in the gas sensor. That's why the nanocomposites I'm using to enhance the gas sensitivity towards the CO2 gas. So how I'm synthesize this polyadenine SNO2 nanocomposite thin film. Firstly, I have take a 0.1 molar hydrolyzed tin chloride pentahydrated material, and it will be mixed with the 50 ml or double distilled water, and keep it for a constant stirring for 20 minutes. So after constant stirring, after 20 minutes, I have added the SCl to make its pH is less than 4, because we have to maintain its pH is less than 4. It should be acidic. Then to make oxides, means we have to form a oxide. I'm adding H2O2, hydrogen peroxide, to form a SNO2 in that solution only. And this is one of the basic solution I have formed. And then by using this, I'm again in that prime solution, I add the 0.2 molar alanine. Alanine is a monomer of the polymer, and keep this solution in ice bath. Ice bath means you can keep it at a less than 0 degrees Celsius. Then after some time, I have removed that solution from the ice bath, and then I am adding a 0.2 molar APS. APS means ammonium persulfate for the polymerization. So during the polymerization in that metal oxides, I simultaneously add the pre-cleaned glass substrate. Why I'm adding the glass substrate? Because during the polymerization, when I insert a glass substrate into it vertically, then what happens during the polymerization, when the color gets changed from the from the brown to greenish color, then it is indicating that the polymerization happened, and this color of the thin film is deposited on the glass substrate. And after polymerization, when I remove the glass substrate and clean with the double distilled water and dried it in the oven, and after which I have to give a electrical contact to it. So by using a silver paint or aluminum foil, you can give the electrical contact to the end of the thin film, which is deposited on the glass substrate, and with the help of this, I can use that glass substrate for the gas sensing material as a glass sensing active layer. So when these glass substrate are placed in a high part per million, means high ppm, high concentration of the carbon dioxide gas, or anywhere where the gas concentration is more, so it can detect. But how it can detect? So that's why I'm using some instrument. I will show you. So I'm doing some characterization. So why I'm doing the characterization? So that material, this nanocomposite is formed properly or not. So as you show the UV visible spectra, from that spectra we can conclude, I'm concluding that, so there are some peaks are observed in the 398, 387, 397. These are the peaks which are to be observed in the polyaniline structure. But due to the addition of the SNO2 nanoparticles, SNO2 metal oxide into it, these peaks are shifted towards the lower wavelength, that is a blue sheet you can say. And but due to that shifting, I can conclude that there is a formation of nanocomposites of polyaniline and tin oxides. At the same time, I observe that I'm making a different solution by changing the molar concentration of the polyaniline and the SNO2. So I observed that the absorption peak at the 427 nanometer, 427 nanometer, then it was found that due to that absorption peak, it is shifted toward the higher wavelength, and it may be because of the addition of the higher molar concentration of SNO2. That means it indicates that there is an existence of the cluster of the SNO2 material in that nanocomposites, and which might be increase the conductivity of that nanocomposites of that 0.1 molar polyaniline plus 0.3 molar of SNO2. So this is the yellow color, which shows the graph shows the yellow in color, which shows the higher conductivity due to the addition of the higher molar concentration of the SNO2. Similarly, I am doing the FTIR Fourier transform infrared spectroscopy. Using this, again, I am confirming there are some basic peaks which has to be observed at the 2313 centimeter inverse, which indicate that there is aromatic vibration, there is NH stretching, and that NH stretching belongs to the polyaniline. Again, I observed some another peaks to 2313, 2380, and this peak because of the CS vibration. But the principal characteristic space of the quinoid and benzoid ring, which is to be observed in the polyaniline, which are observed in 1550.2 and 1512 centimeter inverse, and it shows because of the CN double bond with the N and C double bond with the C stretching, and which is just like a pure pani. That means that FTIR indicate that there is a pani material, means pani is there, that is a polyaniline, and with some modification of the intensity and peak position. And this modification of the intensity of the peak position is because of the when we add a SNO2 molecule. That means the intensity of that peak, which is to be observed at 1550 and 1512, which is to be a slightly decreasing. That means this intensity decreases, it may be, or it could be because of the higher concentration of the SNO2 and which confirm again the presence of SNO2 into that polyaniline. So again, I have taken XRD peak also, XRD pattern of the pani and SN2 nanocomposite. So that middle one graph shows that there is some peaks which you observe. The other two peaks in which the polyaniline molar concentration of polyaniline is more, but and polyaniline is a polymer that's which shows the amorphous nature, that is not a crystalline nature. But when I increase the concentration of 0.3 molar concentration of tin chloride, tin oxides, then some peaks are observed, and which indicate that there is a formation of pani SNO2 nanocomposites. And I compare this data with the acidity data of the card number 41, and which confirm that the SNO2 peaks, which reported the SNO2 peaks. That means in polymer ring, these SNO2 nanoparticles are incorporated very properly. That means we can say that from these three characters, we can say that these polyaniline SNO2 nanocomposites have been properly formed. Now let's move on the sensing characteristics of pani SNO2 nanocomposite. So I'm using the picture which you have seen, where I'm doing a sensing characteristics. There is a temperature controller system. There is a gas chamber which having a proper volume 5,000 cubic volume, cubic meter. There is a Kentley potentiometer which can detect the resistance change. That means the voltage change which can determine. And there is a plate, that is a hot plate, which can increase or decrease the temperature. So, and this is the in that chamber there is a sample holder. So as you see here, there is a glass substrate and I'm placing it on an aluminum foil, and there are the two electrodes in a contact with them. So when I I measure the sensitivity of that glass substrate or Pani SnO2 nanocomposite with increasing the temperature. So as I increase the temperature from the normal temperature to the higher temperature up to the 80 degrees centigrade, I'm simultaneously I measure the changes in the resistance by using the Kentley potentiometer, Kentley 2000. That is the name of that model number of that Kentley potentiometer, and I calculate the sensitivity by using the sensitivity equal to Rg, that is the resistance of resistance when I apply a supply a gas here by using the series, and minus a resistor, and again I remove the gas from that chamber, and again I'm placing a clean air into it. That means I'm getting the two readings: resistance change after supplying the CO2 gas, and resistance of the sample after supplying the clean air. And by using this, I can find out the sensitivity of the material, and I plot the graph which is sensitive versus temperature. So I observe that the sensitivity goes on increasing up to some extent, and I note down the temperature of it. So I observe that for the 0.3 molar polyethylene, there should be a S and there should be a P. 0.3 molar tin oxide, there is the highest sensitivity, that is a 1022 at the temperature of nearly 48 degrees centigrade. So it is very much less than as compared to the 200 degrees centigrade or 800 degrees centigrade. That means due to the combination of the Pani and SnO2, that sensor work is nearly equal to the normal temperature. That means the working temperature of that sensor is coming down. This is the one of the achievement. And then I have also calculate the response time and recovery time. So response time is nearly about the 90 seconds. Means when I place a CO2 gas into that chamber, then it responds, the glass substrate respond to the gas up to 100 seconds. That means near about 1.5 minutes, and in that half minute we can get the highest sensitivity of that gas. So response time is also very low, that is 90 seconds only. And then after removing that gas, and there is again ready for the recovery. Recovery means after deabsorption process. Deabsorption process means when I remove the CO2 gas from the chamber, then I observe that there is a constant rate decreasing. So, but in this case, that recovery time is found to be nearly 150 to 200 seconds only. But it is quite better result I have found due to the combination of Pani and SnO2 for the CO2 gas sensor. Means the conclusion by using this all these characters, I conclude that ki Pani SnO2 nanocomposite thin films was formed properly, and it was confirmed by the XRD, FTIR, and UV visible spectra, and it is highly sensitive toward the CO2 gas at 40 degrees Celsius, which was my aim. That is, it should be work nearly the normal temperature, and it has a fast response time and recovery time, and the sensitivity is up to 1022 percentage, and the response time found to be 80 to 100 seconds, and the recovery time is found to be 150 to 200 seconds. That's why I can say that my material work properly, but there are a lot of scope to again develop that sensors and modification. So I'm working upon it. So these are the references I'm using to make it to study that Pani SnO2 nanocomposite thin film. Thank you so much.
Thank you so much, sir. It was a wonderful session and very informative too. So, sir, do you have any question?
Yes, I just want to discuss so many things because Dr. Nimkar is working in the same direction where I am working. Of course, he is just sensing carbon dioxide and I'm using carbon dioxide as substrate to develop platform chemicals like formic acid, ethyl acetate, and so many other things. So, of course, he is using the material for detecting the things, but I am synthesizing material to absorb the carbon dioxide so that I can get more selective reactions. So, Dr. Nimkar, I was seeing your presentation. Of course, it was very professional and you covered so many things. I just want to know one thing, which is very common question that, of course, there are so many sensors are available. So, how it is novel? How your approach is novel?
Yes, sir. Actually, that works in 2016-17. Now, a lot of work I am doing upon it. But how it is novel at that time, I was thinking that it means whatever literature survey I am doing on metal oxides and polymer. At that time, in metal oxide sensors are commercially used, and the main point is that its operating temperature is so high, and that's why other arrangement I have to do. And my lab is situated in a village place area. That's why I'm not able to doing this. That's why I'm doing this characteristics in the Mumbai Institute of Science in Mumbai.
Yes.
So under the Dr. More sir, PS More sir was there, and he has developed their setup. Again, I'm asking them ki, sir, there should be some proper arrangement. So he told me, sir Shrikant, we can make them, but let's try it for a better. So first of all, do that one thing, ki make a material in such a way that that operate at lower temperature. So at that time my aim was to operate at lower temperature. So I achieved my goal at that time. But how now I am working how it may be commercialized, because as you say, there is a lot of sensors are using. But sir, there is a research we can make it again more, our student or we also working upon it and make it for a commercial purpose. So let's try for another combination. Now polypylar is there, polythiopine is there. So again, I'm working upon it. So let's hope some positive result I will get.
So in your data, like you just actually you are studying the synergic effect of tin oxide and amine.
Polyaniline. Right.
You are just studying the synergic part, the synergic effect of what is the effect of tin and what is the effect of amine. But where is the separate study, like what is the effect of amine only? Maybe the sensing will be, maybe sensor will work more efficiently alone. There is no need of.
So as I told you, sir, I am doing a literature survey upon it. On pani and metal oxides also. Means you can go through the literature survey and separately metal oxides and pani. So you found that some gas selectivity problem is, for example, pani you can take as a sensing material. So it is organic material. So absorption process is there because of the chain structure, but deabsorption process cannot be happened. Means the recovery time is so long. Means nearly 1 hour, 2 hours is required. Means the report somewhere reported I read there. So that's why I'm saying that, means I'm go through the literature. Maybe हो सकता है कि I got the literature which is not to be in my in contact. That is key. Some sensors or pani sensors which shows the better sensitivity and selectivity, and the response time is also less. So maybe हो सकता है कि I am not getting that literature, but whatever literature survey means, I read the more than 50 literature on pani. So I found the selectivity and sensitivity problem is there. That's why my guide also and me also think over it. Let's do the nanocomposites.
Okay, I just want to ask you the last question. Not question. I just want to discuss this thing that, okay, you are using the sensor and the sensor is very sensitive for carbon dioxide gas.
Yes, sir.
So in your preparation, I think you are not following the under organ condition or something like that. So if
Yes.
there is exposure of amine in an atmosphere, so in atmosphere also there is a carbon dioxide. So if it is not carbon dioxide free at the time when you are using them as a sensor, so definitely you will get the lower sensitivity. So how
Right,
you
sir.
are ensuring this thing?
So actually, my aim was to detect the CO2 gases. But if you are using that substrate, means Pani SNO2 nanocomposites for the other gases also, it can detect the other also. But
Yes.
the response may be different at different temperature.
No, I'm not talking about a temperature. Let's say आपका जो surface है जिस पर आप sense करते हो,
हाँ,
when you
हाँ.
are preparing that thing, तो एटमॉस्फेयर में भी तो कार्बन डाइऑक्साइड है ना, और भी गैसेस
हाँ,
हैं,
सर.
तो वो
हाँ.
ऑलरेडी उसके जो साइड्स है उसको सैचुरेट कर दिया उसने पहले ही एट द टाइम ऑफ
हाँ.
सिंथेसिस,
नहीं
and
सर,
when you are
उसमें
using them as a
उसमें
sensor, so
हाँ.
definitely all those sites are already saturated with the gases, and there are
Right,
only
sir.
very few sites are available for sensing. So maybe
हाँ.
your sensitivity is high, but because you are using normal condition for making the sensor, you are not getting that sensitivity which you are looking for it actually.
It may
That
be,
I'm
sir,
asking.
but when I'm using the substrate into that gas chamber, using the vacuum pump,
Okay.
I'm clean that that
Okay.
chamber. Means whatever other substrate of gases are there, we have first of all I'm cleaned it, and then I'm inserting the CO2 gas into it.
Okay.
So to get the proper result.
Okay. Okay.
So
Thank you, Dr. Nimkar. Thank you.
below of that hot plate, there is a vacuum pump, sir. I am not showing here.
No,
But
I
there
can
is a vacuum.
understand. Thank you very much, Dr. Nimkar.
Thank you,
So
sir.
it's okay from my end, Dr. Neelam. Now you can move if you want.
Okay, sir. Thank you so much. Thank you so much for the question. So I would like to invite next candidate, Hariram sir. Are you ready with your presentation, sir? Sir,
Neelam madam, can I leave?
yes, sir.
Thank you.
Hariram sir is present. Sir. Okay. I would like to invite our next candidate, Ankit Gupta sir. Sir, will you share your screen?
Hello, ma'am, I am audible.
Yes, sir.
yes,
Yes, sir.
hello.
Yes, yes, sir.
Yes, I am sharing my screen.
Yes. Yes, sir. Please continue.
Okay, so may I start my presentation?
Yes, sir. Sure.
So, good afternoon to everyone. I am Ankit Gupta, and I am going to present my presentation on experimental investigation of force transmissibility for natural fiber composite materials. I am assistant professor in Acropolis Institute of Technology and Research, Indore. So, very first, I just want to introduce what is vibration. Vibration can be defined as displacement of a body about its mean position during running conditions. Sometimes vibration is not essential, and sometimes it's desirable, but it always finds there when the machine is in running condition. So for reduction of the effect of vibration on the machine, we have to overcome the transmission of force generated through vibration, and it can be done by providing some isolation, which is known as damping process. So the aim of this research paper is to analyze the isolation characteristics of various natural fiber composite materials by experimentation. So the result of experimentation give the comparison among the force transmissibility of all natural fiber composite material and conclude about the best possible solution of the natural fiber composite materials. As we all know, vibrations are undesirable for structures due to the need for structural stability, position control, durability, performance, and noise reduction. Vibration are also concerned with large structures such as aircraft as well as structures such as electronics devices. Vibration reduction can be attained by increasing the damping capacity and or increasing the stiffness. And damping of the material, any structure can be attained by passive or active method. And I am totally focused on the active damping process. So I'm going to utilize fiber reinforced composite material. Why it is so? Because these are very increasingly used as alternative for conventional materials, because they have very high specific strength, specific stiffness, and we can easily tailor their properties. In addition to the viscoelastic characteristics of the composite, render them suitable for high performance structure applications like aerospace, marine, automobile, etc. So for this purpose, I have chosen the 4 composite materials. Just like my first composition is about coconut fiber composites, then next one is jute fiber composite, third one is banana fiber composite, and fourth one is coconut fiber with rice husk composite. So I prepare all these 4 samples on compression molding machine, and these all are the 4 samples which I get from this compression molding machine. After that, I fabricated this particular experimental setup on which we can perform all the tests of force transmissibility on, as you can see in the experimental setup, there are 2 plates, one upper aluminum plate and another one is lower aluminum plate, in which in between them we can place our isolator or vibration damper. So with the help of a vibrating machine, we can generate the vibrations and analyze the force which is generated on the upper plate and lower plate. And with the help of these particular 2 plates, we can find out what will be the exact amount of force which is transmitted by a particular vibrator damper. So effectiveness of the vibration isolation is measured in the terms of ratio of force motion transmitted through the isolator to the amplitude of the excitation force motion. This is called transmissibility. So ultimately we can say force transmissibility is nothing. It is the ratio of force transmitted to the foundation and force impressed upon the system.
Ankit sir, sir, your slide is not moving, sir. Please try to move the slide to the slide you are presenting.
I'm actually, I am on the 7th slide.
Sir, please put it in on slide mode. So it will be. Sir, share a screen and put it in slide mode.
Now it is visible, ma'am?
Yes, sir. Slide mode पे कर लीजिए, sir. Please. नीचे
मैम
icon.
स्लाइड मोड भी किया था पर वो दिख नहीं रहा था. Now it is visible and moving.
Yes, sir. Yes.
Okay.
Please.
So force transmissibility is nothing. It is the ratio of force transmitted to the foundation to the force impressed upon the system. As we can see, this is the formula for calculation of the transmissibility ratio. And after performing the transmissibility ratio, we can get this kind of graph for different frequency ratios and different coefficient of damping. So transmissibility is nothing. It is the ratio of amplitude responsible for the vibration. So it can be also measured in the vibration energy form. So isolating material reduce transfer of vibration energy from support to the structure and vice versa. So this vibration energy is calculated in the terms of decibels. So the we can see from the graph, the peak on the curve is around 35 Hertz and is representative of that material's natural frequency. So when the curve crosses the y-axis into negative values, it means approximately 60 Hertz on the plot above, the material begins to isolate the vibrations. So if I got the values like this particular phenomena, so we can say it is a good kind of isolator. So how we can calculate the effectiveness in decibels? The formula for this particular is effectiveness in decibels is equal to 10 logarithmic value of 1 by transmission.
Ankit sir,
Yes,
sorry
ma'am?
to interrupt. Your slide is not moving to the slide you are presenting on.
Ma'am, now it is moving.
Now it is moving, but when you are presenting the slide, it will not move, sir.
Okay. So ma'am, can I present in this particular mode only?
Yes, sir. Please continue.
Okay. So this is my table. I hope my screen is visible now, ma'am.
Sir, I can't see the table actually.
It is just written like analysis table of composite materials.
1 minute, sir.
Yeah.
So this is the table in which I already performed the transmissibility of different particular materials of different composite material on different speeds. So we found the different acceleration value at lower plate when we transmit the force, and this is the acceleration on upper plate. It can be measured by accelerometer, as I already saw into our experimental setup. So we easily calculate the what will be the excitation force and what is the transmission force, and we can get the transmissibility ratio of the particular composite material. So in this manner, I perform the transmissibility ratio for all the 4 composite material which I fabricated. Then we can easily calculate what will be the effectiveness of the isolation in the terms of percentage, and we can also see the effectiveness in decibel form. So as I already tell you, if the value of R, if it is comes out greater than 1, so it will provide us a great transmissibility of the force, and it will become a great isolator for the particular machine. So by this particular table, I just prepared this particular graph by which we can compare all four the composite materials, and we can conclude that the graphs plotted between transmissibility versus speed, the common factor is as the speed of regulator increases, transmissibility also increases. And for coconut fiber composite, the increment in transmissibility with the speed is quite less as compared to the remaining all 3 materials. So this makes them for suitable option for vibration isolating for varying load machines. If we are utilizing any varying load machines, so we can utilize the composite material fabricated by coconut fibers. Coconut fiber with rice husk provides great fluctuations after speed number 3rd. So it makes them suitable for slow speed machine. We can utilize them for slow speed machine. And the negative value of transmissibility ratio defines that the frequency ratio are in acceptable range for all materials. If we want to place all the materials in the what you can say what are their vibration isolation capacity, so we can arrange them in this particular manner. First one is banana fiber composite, which have very less damping capacity, then coconut fiber with rice husk composite, then coconut fiber and jute fiber composite. Jute fiber composites are showing very good performance at all speeds, and mean effectiveness of jute fiber composite is approximate 83.5%, which is very high compared to the other material. And banana fiber composite shows very little what you can say the damping capacity of 26% only. And these plots are showing similar relationship as I shown into the figure number 1. So we can say this analysis verified theoretically as well as practically. So these are my references. Thank you. Now I am open up for questions. Any questions, sir?
Thank you so much, sir. Sir, any question?
Yeah. So actually, I just missed some previous slides because it was not moving.
Yeah, sir. I am sharing.
Can you just show the picture where you are making something, the synthetic part? I think there is one slide where some instrumentations are there, how you are making these composites.
Sir, what you want to see?
Yeah, this one, the 6th one and then 7th one. So this is your thing is there.
Yes, sir. This is my experimental setup. 7th.
Yes, okay. And what about the 6th one? 6th slide number.
So these are the samples.
Okay, that's your sample. You prepared the composite for coconut fiber, jute fiber, coconut with rice husk composite, and then banana fiber composite. So how you prepared this composite?
So these composites are fabricated on compression molding machine.
Okay, मतलब आपने कोकोनट का फाइबर लिया और आपने प्रेस कर दिया और ऐसा मटेरियल बन गया.
No, sir.
Actually,
there is one
because the slide was not moving. So maybe you discussed, but I missed.
Yes, sir. Actually, on compression molding machine, we can utilize some composition, right? These are the compositions which we can utilize to fabricate. So we have to prepare one die.
Yes.
Yes. So we have to create one die of ASTM standard, and according to which we can prepare a die, and die will be established in that particular compression molding machine. And in compression molding machine, we can put epoxy and hardener and coconut fiber according to the orientation. We can generate the different samples.
ठीक. So
I
can
hope you are able to
the
understand.
slide number 5?
Yes.
Yes. So in this, it is written like resin 96 gram, hardener 84 gram, coconut fiber 20 gram. So why 96 gram? Why not 90 gram epoxy resin?
Actually, sir, I got these particular compositions from my literature review. So by literature review, I found that if we are mixing in this particular amount, so we can get some desired properties like tensile strength and flexural strength in appropriate mix. So that's why I mixed this particular epoxy in 96 grams amount.
Okay.
Yes.
So according to you, if you are using coconut with rice husk, then it is good. So what actually you want to make with these composites?
Sir, because these composites can be utilized to prepare some dampers, like if you want to install a engine in particular chassis. So below there, we have to provide some dampers that can absorb the vibration. And as well as we can, yes, sir.
Sockers. जो shock
absorber
type
in
हो गया.
another manner we can see shock absorber. Yes, sir.
Shock absorber. Okay.
Yes, sir.
So wherever you are using these shock absorber, normally the conditions are very wet at that place. मतलब कहीं कीचड़ होगा, कहीं पानी होगा, तो इनकी तो लाइफ तो है नहीं कीचड़ और पानी के लिए. मतलब they get swell or exfoliate.
Yeah. Actually, sir, my motto is that I want to fabricate a particular composite material which is very well behave in vibrating conditions. And after that, I can analyze that where we can utilize this particular kind of composite material. Because if a coconut fiber with rice husk, I cannot utilize them into very high temperature. So we can use them in that particular applications, like we can generate the cushion effect for the what you can say the vehicle seats, where the vibration absorption is main feature apart from the other conditions.
Because vibration feature is only workable when the condition like moisture and other things should not be like that. Means these materials should not be moisture sensitive or air sensitive. Then only your vibration feature may work. But if it is moisture sensitive, then I don't think so. It is good for the absorbing the vibration.
Sir, actually, I get the data, and there are various places where we can utilize this composite material for vibration absorption, because right now there are various places where these types of composites are utilizing, like fabrications of the what you can say drilling machine outer body. They can fabricate it like this, and we can even though fabricate the structures of like what you can say the bodies of the vehicles. Because they are also just like the doors of the vehicles, and this can be fabricated by this kind of composite.
Okay, what is hardener?
Where the temperature factor
what is hardener?
Yes, sir.
What is hardener? In your slide,
sir,
it is
actually, I am not able to
hardener
get
84
your voice is
gram.
not clear. The hardener is nothing. It is a kind of what you can say. It is easily available in the market. You just utilize epoxy and hardener, which can harden the epoxy in a very well manner. So that is just the what you can say, chemical composition.
Okay, so thank you very much. Now that's next slide.
Thank you, sir. Thank you, sir.
Thank you so much, sir. With this, I would like to invite our last candidate, Hariram, sir. Sir, Hariram, sir. Sir, please
Yes, madam.
your slide.
Yes, madam.
Please share your slide. Ankit, sir, please disconnect your slide. Stop sharing your slide first. Okay. Hariram, sir, please share your slide.
Yes, madam.
Sir, share your slide.
बस 1 minute मैडम, 1 minute कर रहा हूँ मैं. WhatsApp पे ले लो. वन मिनट बस मैडम, 1 minute. मैडम विजिबल हो रहा है मेरा स्लाइड?
No, sir.
शेयर हो रहा है? शेयर हो रहा है मैडम स्लाइड? विजिबल है?
Yes, sir, it is visible. Please present.
Yes, my topic is study of physico-chemical parameters of underground water, Shekhawati division of Rajasthan. Abstract: the Shekhawati region consists of Sikar, Neemka Thana and Khandela of Rajasthan state has various type of groundwater problems. The various diseases found in these region and fluorosis, blue baby syndrome or the methemoglobinemia etc. for our purpose. We took sample from the Shekhawati region in Rajasthan state consists of Sikar, Neemka Thana and Khandela, and by determining various parameters such as pH, electric conductivity, total dissolved solids, total hardness, alkalinity, nitrate ion, calcium hydride, magnesium hydride, chloride ion, and fluoride ion. Keywords: groundwater, physicochemical parameter, pH, EC, TDS, TH, alkalinity, calcium hydride, magnesium hydride, chloride ion, nitrate ion, methemoglobinemia, and the fluoride fluorosis Shekhawati region. Introduction: water is one of the most important and most precious natural resources. It is vital to man's existence, and without it, there would be no life or no earth. In various places, groundwater discharges naturally into natural spring or the contributed to rivers and wetlands. During drought, groundwater often play a vital role in sustaining river and the streams and become a valuable buffer. Groundwater is infinite in the finite resources, and the aquifers can become depleted when the extraction rates exceed replacement or the recharge rates. Like surface water, groundwater can become polluted or contaminated. The objective of this study are to find the groundwater critical zone in Rajasthan, identify the seasonal variation of the groundwater level and the trends of groundwater level and the locations. Rajasthan is a state with low to extremely low rainfall, intense summer with very high temperature, high diurnal variation of temperature and low humidity and the high evaporation. It is one such Indian state with complex agroclimatic zone and in urgent need of expanding groundwater resources. Moreover, increase in population and the urbanization leads to groundwater depletion. Thus, groundwater study play an important role in assignment, monitoring, planning, development, and the integrated water resources management in Rajasthan. The 33 districts of Rajasthan have been affected area by fluorosis. Out of them, Nagaur, Jaipur, Sikar, Badmer, Ajmer, Siroi, Jhunjhunu, Churu, Bikaner are in the very worst conditions. Some tehsil of Jaipur district, Amer, Chomu, Jamua, Ramgarh, and Kotputli and Viratnagar, etc. Fluoride problem is very high. Area of study area, Shekhawati region, 270,527 kilometers, included the district of Sikar, Jhunjhunu, and Churu in Rajasthan state of India. Shekhawati division of Rajasthan is the semi-arid zone that receive a normal annual rainfall of 527 mm and the average annual rainfall is 565 mm. For the last 30 years, 90% of the total annual rainfall is observed during monsoon. The Sikar district is situated in the northeastern part of the Rajasthan and lie between 27°38' and 28°31' north latitudes and the 75°02' and 76°06' east longitude. Material and method: sample collection and physiochemical investigations. The groundwater tests are gathered from tube wells and the hand siphons for the facultating facultated that water sample of about 2 liters from the each sampling site has collected in the pre-cleaned and the ranized polythene bottles. In the present study, the total number of sample total water collection in the year of 2019, they divided into two seasons. One is pre, which included pre and post monsoon. Monsoon July, and the another is post season 24 sample monsoon September and October in the Shekhawati region. A grape groundwater sample were collected. Sampling is applied during the sampling with standard analytical method. 24 groundwater samples were collected in the Khandela, Nimka Thana and Sikar from the tubewells and borewells, which were used for the drinking water of the study area. Water samples were either taken from the pumps or down by the buckets and collected in the clean and the round plastic bottles, labeled properly and carefully correct, brought by the laboratory for the further analysis for the EC, pH measure, cation and anions such as sodium ion, calcium ion, magnesium ion, potassium ion, chloride ion, bicarbonate ion, carbonate ion, and sulfate ion. The value of sodium adsorption ratio and the residual sodium carbonate were also calculated. Use of the method: pH by the digital pH meter, EC by the Siemens in per meter digital conductivity meter, TDS digital conductivity meter, total hardness, titrimetric method, and calculation and management of the hardness, titrimetric method, total alkalinity, titrimetric method, sulfate, turbimetry methods, nitrate, spectrophotometric method, chloride, titrimetric method, and fluoride ion selective methods. And then after result and the discussion. At table number 2, physiochemical parameters of groundwater of the Shekhawati region, Sikar, milligram per liter. For the Sikar, Khandela, and Nimka Thana, the pH, EC, TDS, alkalinity, total hardness, calcium hydride, magnesium hydride, nitrate, chloride, and fluoride ion, their measurement value in the tables. Then after pH, the Shekhawati region of Rajasthan state consists of the Sikar, Nimka Thana, and Khandela. The pH vary from the 7.1 to 8.2, which is considered as normal. Electrical conductivity. Electrical conductivity, the permissible limit of EC is 2100 ms per centimeter, and in the Shekhawati region consisting of Sikar, Nimka Thana, and Khandela, for which is slightly lower than normal in some region. Table number 2. TDS for drinking water, the desirable concentration of TDS is less than the 500 ppm and maximum allowable limit is 1500 ppm. Normal is some region. Alkalinity, bicarbonate, carbonate, and hydroxide contribute essentially to the alkalinity or acid neutralization power of water. And in Shekhawati region consisting of Sikar, Nimka Thana, and Khandela, high alkalinity. The determination characteristic of bicarbonate, carbonate, and hydroxide are usually considered in the light of their association with alkalinity, and hardness is also included in table number 2. Total hardness, Shekhawati region consists of Sikar, Nimka Thana, and Khandela. High hardness range important in the food preparation and cooking and affect human body. Calcium hardness, as per WHO and ISI standard for the drinking water, the desirable limit of calcium is 75 ppm. And in Shekhawati region consisting of Sikar, Nimka Thana, and Khandela, calcium high range all blocks. When one taken up large amount of calcium, this may negatively influence human health. Metallic calcium coats the skin when it come in connect with the skin, eye, and mucous membranes. Magnesium hardness. Magnesium limit is 100 ppm. Shekhawati region consisting of Sikar, Nimka Thana, and Khandela, magnesium high range all blocks. Chloride. As per the ISI standards, the high desirable limit of chloride for the water is kept at 250 ppm and maximum permeable limit is 100 ppm. In Shekhawati region, consists of Sikar, Nimka Thana, and Khandela of Rajasthan state is vary from the 300 to 500 part per million, which is considerable as desirable limit. Nitrate ions. The maximum permissible limit of the nitrate in the drinking water is 45 ppm according to the ISI and WHO investigation. So that the nitrate level range from the 10 to 245 part per million included in the table 2. Shekhawati region consisting of Sikar, Nimka Thana, and Khandela. Such high nitrate level in water are responsible for the methemoglobinemia or the blue baby syndrome. Fluoride. According to WHO and standard, prescribed limit of the fluoride is 1.0 to 1.5 ppm in drinking water. Shekhawati region consisting of the Sikar, Neemkathana and Khandela of Rajasthan state is vary from 1.6 to 3.0 ppm. High value irrigation water Shekhawati region consisting of the Sikar, Neemkathana and Khandela block in each area. High value of fluoride most commonly in the drinking water can causes fluorosis which affected the teeth and the bone. Chronic high level exposure of fluoride can lead to skeletal fluorosis include stiffness and the pain in the joints. A conclusion. The current study is focused on the study of physiochemical parameters of the Shekhawati region pre-monsoon, and this study were used various parameters consisting of pH, ECTDS, TH alkalinity, nitrate ion, calcium hydride, magnesium hydride, chloride and fluoride ion, and we found that in the Sikar region, pH, EC, Cl, chloride and fluoride ion are lying in the normally range, where magnesium hydride and calcium hydride, TDS, total hardness, nitrate, alkalinity are the higher than the desirable limit. Where as in the Khandela region, pH, TDS, chloride and fluoride are the lying in the normal range, and the magnesium hydride, calcium hydride, nitrate ion, alkalinity, EC, total hardness are higher than the desirable limit. And at last in the Neemkathana region, pH, EC, TDS and chloride and fluoride are lying in the normal range, whereas magnesium hydride, calcium hydride, nitrate, alkalinity, total hardness are higher than the desirable limit, which is ultimately causes various disease and the health problem in the Shekhawati region of Rajasthan state. References RH. Thank you. Am I audible?
Yes, sir. Yes, sir. Thank you so much, sir. Sir, Vivek, sir, do you have any question?
Yes, first of all, Hariramji, in your case also, there are a lot of typo errors.
Yes, sir.
ठीक है, तो आप तो पहले उसको सुधारो क्योंकि now you are a PhD student, so at least you should know how to write.
Yes, sir. Some of mistake by
हाँ नहीं जैसे PH वही आपका भी PH कैपिटल ही है और Cl भी कैपिटल है क्लोराइड आयन वाला. फिर
Yes, sir. Yes,
जगह आप स्टडी कर रहे हो सारे नाम आप स्मॉल लेटर में लिख दे रहे हो जबकि कैपिटल में फर्स्ट तो कैपिटल में होना चाहिए था. जैसे नीम का थाना आपने लिखा तो n छोटा नहीं होगा ना, n बड़ा होगा. दूसरा, इंस्टेड ऑफ जस्ट रीडिंग द स्लाइड यू कैन यूज वन मैप टू डिफाइन दैट व्हाट इज योर लोकेशन. मतलब ये मेरा का थाना, तो आप उसी में बता दो ना एक बार में एक मैप में. आप इतना क्यों पढ़ क्यों रहे हो सारी चीजें, वो तो मैं भी पढ़ सकता हूँ.
Yes, sir. Yes, sir.
ठीक है. और दूसरा, वट एवर रेफरेंस यू आर यूजिंग, इट इज वेरी ओल्ड. दैट इज वेरी ओल्ड.
Yes, sir.
वो तो आज के हैं भी नहीं रेफरेंस. मतलब 2013-10 उसका कोई मतलब नहीं है. 10 साल पुराना तो रेफरेंस भी हम नहीं यूज करते हैं. आप तो बहुत पुराने यूज कर रहे हो.
Yes, sir. Yes, sir.
तो ये थोड़ा आप देख लो और इसको सही से करो. मतलब अभी आप स्टार्टिंग फेज में हो, सो दैट
बिल्कुल सर. Yes, sir.
Thank you, madam. Thank you very much. It's over from my end.
Thank you so much, sir, and thank you all the participants to give your valuable time to us, and thank you so much, sir, for your valuable time and consideration and for the suggestions also. So now we are come to the end. So participant can leave the session, and sir, thank you so much. You can also do.
Okay. Thank you.